Hello, welcome to 10.2 Day 2. Today we're going to see what happens when we have a match pairs design. Now, match pairs design in Chapter 5 is when we match similar people, and sometimes same people, up, and one goes through the control and the other one goes through the treatment. So a paired T procedure is to compare the responses to two treatments in a match pair design or before and after measurement on the saved subjects. Apply one sample T procedures to the observed differences. The parameter mu in a paired T procedure is the mean difference in the responses of the two treatments within the match pairs of subjects in the entire population. When subjects are matched in pairs, or the mean difference in response to the two treatments for individuals in the population when the same subject receives both treatments, or the mean difference between before and after measurements for all individuals in the population for before and after measurements on the same individuals. So here's an example. 11 subjects are dependent on caffeine. Each subject was banned from using caffeine, but took a pill that was either placebo or a caffeine pill. Some tests were done to measure their depression level and heart rate. So let's go through this and make a 90% confidence interval for the mean change in depression score. So the first thing you want to do, they're looking at depression score. So let's look at these values. This is subject 1, 2, 3, up to 11. And this is their depression score when they got the caffeine pill. And this was their depression score when they got the placebo pill. So sometimes that went up. This instance it went down. Sometimes it went up dramatically. So let's see if they're what the difference is. So we're going to look at our parameter. And our parameter is we want to find the mean difference in depression scores between caffeine and placebo. It's EI. All right, our conditions. Data does not come from our SRS. So we have to proceed with caution on this, knowing that we probably can't generalize this as well as we could have. We have to look at normality. So for normality, there is not enough data points to say that this would be a normal distribution by the central limit theorem. So what we have to do is put this in L1, put this in L2, pause the video and until you're done with that. Then in list 3, we want to have L3 equal L2 minus L1, so we can get the differences of it. Now we'll want to graph L3, so we want to turn on a dot plot, and our dot plot has to be for L3. Now our plot looks something like this. Now this is skewed, but it's not skewed enough to say that the data is not normal. So we can say the data is approximately normal. Oh, I ran out of room for approximately. I'll erase it and go at it again. Data is, oops, this is going nuts on me. I'll write it below. This box plot doesn't have strong skewness rollers. Now, data are independent if there are more than 110, because 11 times 10, caffeine-dependent people. And that's got to be true. All right, so now we go to our calculations. Now, we have L3. Our L3 is going to be our differences. So let's go to one variable stats of L3. And because remember, it's x bar plus or minus t star times s over the square root of n, because we don't know the standard deviation for the population. Our x bar for one variable stats is 7.36 plus or minus our t star. Now our t star, we have to look back at our charts. So on our charts, we have 11 data points, so our degree of freedom is 10, and we go over till we hit the 90% confidence interval. That looks like it's 1.812. So let's go back to this. 1.812, and our standard deviation is the S of x from one variable stats. So that's going to be 6.92 over the square root of n, which is 11. So now I take 1.812 times 6.92 divided by the square root of 11, and I get 3.78. 7.36 minus 3.78 is 3.58. All the way up to 7.36 plus 3.78, 11.14. So that is our confidence interval for our interpretation. We are 90% confident that our true mean difference is between 3.58 and 11.14. So one thing that's really interesting about this is since 0 is not in this interval, we are really confident, or we're pretty confident, that there is an effect on having those caffeine pills versus having the placebo on your depression. So if you're dependent on caffeine, it looks like you're going to be more depressed if you have the placebo pills than if you're just having caffeine. So that's where that gets interesting. Now, one thing we have to realize the difference between is random selection and random assignment. Random selection allows us to generalize our results to a larger population. This is when we want an SRS. A random assignment of treatments allows the experimenter to see if the treatment caused an effect in the response variable. So in a treatment, we're going to do a random, I'll say random assignment, and put 5 people in this group, 5 people in this group, and he does that to have so there's not any bias, and he can see if the treatment actually caused the effect, because there's it evens out the groups. Now, robust procedures, this is a new word. An inference procedure is called robust if the probability calculations involved in that procedure remain fairly accurate when a condition for use of the procedure is violated. For confidence intervals, this means that the stated confidence level is fairly accurate. T procedures are not robust against outliers because the mean and standard deviation are greatly affected. So if it was robust, it would mean that if there was an outlier, it wouldn't be a big deal. But since they are not robust, it is a big deal. Now, when using T procedures, it's pretty much the same as before. If n is greater than 30, the central limit theorem tells us that it's approximately normal. If it's at least 15, T procedures can be used except in the presence of outliers and strong skewness. If it's less than 15, we want to use T procedures if it's close to normal. If the data are clearly not normal or if there are any outliers present, then we don't want to use the T procedures. All right, here's your homework for tonight. Good luck.